Okay, finally, negative binomial distribution. So x is the number of trials to achieve the R success. So that's one of your parameters. And that's dependent on the fixed probability of success, P. And the probability x is equal to x, so it takes x trials to get R successes exactly. Then it's the probability of getting x minus 1 successes. No, sorry, R minus 1 successes in the first x minus 1 trials. And then when you times by P, that will make your final success on your xth trial. And then that comes down to give you that formula there. So it's the binomial on x minus 1 trials times P, which gives you that formula. I will go over the finding a probability generating function for x, but there's a little bit in this proof that it's slightly beyond what you need. I'll show you when we get here. So a biased coin for which the probability of heads is 0.6 is tossed until heads has come up 5 times. And we want x to represent the number of times the coin is tossed up to and including the 5th head. Find the probability generating function for x. So x is negative binomially distributed. R is 5 and it's biased, so P is 0.6. And again, I'm going to do this in a table and then pop the algebra in. So probability distribution for x. And that will start on 5. So then you'll have your 5th success on your 5th trial. And then keep going. Again, it's an infinite distribution. Don't really feel like I need to go past there. And so the probability you get your 5th success on your 5th trial will be 0.6 to the power 5. The probability you get your 5th success on your 6th trial, you'll have had 4 successes on your first 5 trials. So this is where this formula is coming in. So 5 choose 4, 0.6 to the 4. I'll also have 1 failure. And then I need to times that by 0.6. And then moving on to the next one, you'll want 4 successes in the first 6 trials. So that would be 6, choose 4, 0.6 to the power 4, 0.4 squared times 0.6, and then we now are going to need 7 choose 4, 0.6 4, so we still had 4 successes, but this time we've had 3 failures, and then times by that last success on the 8th trial. So just building up that formula. Obviously these are numbers, so 5 choose 4 is 5, 6 choose 4 is 15, I believe. Yeah. And 7 choose 4. I'm going to have to pop through my calculator. No, I can't find it. That's handy. I might have to let you do that bit. Oh, here it is. 7 choose 4. $35. which takes us to there. Right, and then the probability generating function for x is equal to the sum between x equals 5 and infinity of the probability x equals x times by t to the power of x. And then it's just sorting through this algebra. So plugging into here, I've got 0.6 to the 5, t to the power 5 plus 5, 0.6 to the power 4, no, sorry, to the power 5, .4 t to the power 6 plus 15, 0.6 to the power 5, 0.4 squared t to the power 5 plus 35, 0.6 to the 5, 0.4 cubed, and then we're on t to the power 6. No, 5, 6, that should have been 7. And I'm now on t to the power 8, sorry. So, yeah, that looks better. And then from there, we can do what we can with the factorising. So I can pull out 0.6t to the power 5 from all of this. And then that would give me 1 plus 5 lots of 0.4t, and then plus 15 lots of 0.4t squared, plus 35 lots of 0.4t cubed, plus. And this next bit is the bit that's kind of taken a little bit of a quantum leap, and I really don't think you need to worry about this in terms of exams. But the next line from here, I should have room if I start there. Hopefully you can see that. Yeah. So I've got 0.6t to the power 5, and this here is the binomial expansion of 1 minus 0.4t to the power of minus 5. Remember, we're in the negative binomial distribution, which is why we're getting this kind of effect coming through here. You could expand that backwards and you'd be able to see that you get this. Don't worry about taking it the other way. And so that goes to 0.6t to the power 5 over 1 minus 0.4t to the power 5. So I'm just bringing that negative power underneath the fraction. And then I can pull the power 5 out of all of it, and you get 0.6t all over 1 minus 0.4t to the power 5. So you can split a power, obviously, across a fraction. That takes us to there. So don't overly worry about that. The proof's a bit beyond where we need to be, I think. I'll let you think about that if you want to try a little proof. And then, so from there, we can talk about the probability generating function of the negative binomial distribution. And so the probability generating function for the negative binomial distribution is equal to pt over 1 minus qt, or 1 minus pt. And again, that's given to you. You don't need to memorise all of these, but you can see that doing? 0.62. I'm worried about this power now, sorry. I think I meant to put the power in my notes, which I didn't put in. But I feel like I need to double check, sorry. Sorry. Just double check. Yeah, or to the power of t. I didn't write that in my notes. There we go. So there's a probability generating function for the negative binomial distribution. Oh, I'm on the wrong page in my notes. Okay, so without the power, so when you get pt over 1 minus qt, that's your geometric distribution. And when you raise this to the power of t, then to the power of r even, then you're in the negative binomial distribution. Sorry about the end of that, I hope that's okay. So without the power, it's geometric, and if you raise this to the power r, that gives you the probability generating function for the negative binomial distribution.